The following presentation is about composite functions and function operations. Composite function is the result of when we use one function's output as another function's input. The notation you can see for composite functions below. The way we pronounce this is f of g of x, which means we plug the g function into f, or we can have g of f of x, which means we plug the f function into the g function. So let's say we have two functions, f of x is equal to x minus 2, and g of x is equal to x squared. So the way you do this is you plug a value into the inside function first, then plug the result into the outside function. So I bet you're wondering which one is the inside function. The inside function is the letter closest to the number. So in this situation, we have f of g of negative 5. You plug the negative 5 into the g function first. So negative 5 quantity squared is equal to 25. And then you take that result and you plug it into the f function. So we have 25 minus 2 is equal to 23. Therefore, f of g of negative 5 is equal to 23. So this example we have g of f of negative 5, so that means f is the inside function this time and g is the outside function. So you take the negative 5 and you plug it into the f function first, so negative 5 minus 2 is equal to negative 7. You take that negative 7 and you plug it into the g function, which is x squared. So negative 7 squared is equal to 49. So g of f of negative 5 is equal to 49. We can do several operations with functions. The first notation that says f plus g of x, all that means is we take our f function and we add it to our g function. F minus g of x is the f of x function minus the g of x function. F times g of x just means you take the f of x function and you multiply it by the g of x function. And f divided by g of x is f of x divided by g of x. One of the biggest mistakes that tend to be made with this section of the chapter is people confuse f times g and f of g. So if you take a look, the f times g, there's just a dot between, and the f of g is the composite function symbol. So again, you have to pay attention to which symbol you have because they are not the same. All right, so we have f of x is equal to 3x squared plus 10x minus 8, and g of x is x plus 4. So f plus g, all we do is add the two functions together, and then if we have any like terms, we combine those. So we have 3x squared plus 10x plus x, that's where the 11x comes from, and negative 8 plus 4 is minus 4. F minus g, same idea, except for you distribute the negative into the g function, so we get 3x squared plus 9x minus 12. Don't forget to distribute the negative to both pieces of the function. F times g, and again, this is not to be confused with f of g. We are going to distribute the x first, and then you're going to distribute the 4 second, and then you're going to combine any like terms. So after you distribute both terms and combine like terms, you get 3x to the third plus 22x squared plus 32x minus 32. And lastly, f over g, we can factor g of x. G of x can be broken down into the factors 3x minus 2 and x plus 4. We can cross out both of the x plus 4's, and our final answer is 3x minus 2. So those are the 4 different operations we could do with the f and g functions. We have to be careful for domain restrictions. So in this situation, we ended up with a fraction, and the domain restriction here is x cannot equal -4 because we cannot have a 0 in the original function. So you take a look at your original function, you set your denominator equal to 0, and that gives you your domain restriction. The following function, g of f, will also have a domain restriction because the original f function has a restriction. So g of f of x, we're going to take the f function and plug it into g. So we have x minus 5, quantity squared, plus 6. The square root of x minus 5 is going to cancel out, add 6, we get x plus 1. Even though x plus 1 does not have a restriction, the original problem had a restriction where x has got to be greater than 5 because we can't square root a negative in the original f function. So we have f of x equals 2x plus 5 and g of x equals x squared minus 3x plus 2. First we have g of f of -1. We're going to plug the -1 into the inside function first. Our inside function is the f of x function. So when you plug -1 into 2x plus 5, you get 3. And then we take the 3, plug it into the g function. And then our final result of g of f of -1 is equal to 2. F of g of a, we take the a and we plug it into the g function. So we have a squared minus 3a plus 2, can't simplify that anymore. And you take the a and you plug it into where the x variable is in the f of x function. So that whole entire function gets plugged in to where the x is. So we have 2 times a squared minus 3a plus 2, distribute the 2, add the 5. Our final answer is 2a squared minus 6a plus 9. -3 times f of x plus 2. We have -3, distribute into the parentheses, and then add the 2, -6x minus 13. The next example, we have 4 times f of x plus 2 times g of x. We're going to multiply the f of x by 4 first, and then add it to 2 times the g function. Distribute the 4, distribute the 2, combine any like terms. Our final answer is 2x squared plus 2x plus 24. The next problem has 4 times f of x times 2 times g of x. So we're going to start this off in a similar fashion. We're going to distribute the 4 and distribute the 2 just like I did in the previous problem, but now we're going to multiply these two polynomials together. So you distribute the 8x, you distribute the positive 20, and combine any like terms. So we have 16x to the third minus 28x squared minus 88x plus 8. And then f of x divided by g of x, we have 2x plus 5 divided by x squared minus 3x plus 2. When I factor the denominator, I end up with x minus 2 and x minus 1, and I know those two can't equal 0, so I'm going to have a domain restriction. The domain restriction here is x cannot equal 1 or 2.